All right, today's integration technique is completing the square. And there's also another little kick to it, which we'll see later. All right, so first of all, here are three integrals for your consideration. You should be able to do the first two, but you might not be able to figure out how to do the third one. So take a stab at the first two and see if you can think about the third one and see if you can get it, and then come back. All right, so number one should be really straightforward, and like this is going to be a really important one to know. We see integral of 1 over x squared plus 1. That's inverse tangent, right? Because the derivative of inverse tangent is 1 over x squared plus 1. I told you when you learned that was going to be important. This is why. All right, now, so how are we going to do this one? Well, it looks like we could think of there being an inside function, right? So this is really, think of it as the integral of 1 over 3x squared plus 1. And then this is an inside function, u, and in fact it's a linear inside function, right? So what I can do, and don't forget my dx here, is I could write out the substitution u equals 3x, du equals 3dx, 1/3 du equals dx. Or I could use the trick that we use for linear u substitutions, which is we just do the antiderivative of the outside function. So the outside function here is 1 over u squared plus 1. So that's going to be inverse tangent, all right? But I keep my inside function the same, my u, 3x, all right? So I keep my u the same. And then what I multiply is, I've been calling it 1 over g prime, but maybe it makes sense to call it 1 over u prime. Right, so u prime is 3, so it's times 1/3, and then put my plus c. Right, so that means that integral is a nicer way to write that would be 1/3 inverse tangent of 3x plus c. All right, so that's that one. So you do a u substitution. So if I have the 9 in front of the x squared, I can just say, let's consider that to be an inside function of 3x. And then I can, multiply by 1 over the derivative of that inside function. Or if you prefer, you can write out the substitution u equals 3x, du equals 3dx, 1/3 du equals dx, and then go from there. All right, but this one's a little trickier. So it's not at all obvious what to do with this one. So there is a trick. And the trick is you do a u substitution, even though there does not appear to be an inside function. What we do is we create one. So what we do is we're going to say u equals x over 3. Why x over 3? Because 3 is the square root of 9, and it works. All right, so the result of that is that you have 3u equals x. We're going to multiply by the 3 right away. And then 3 du equals dx. All right, so by doing that, normally when we do substitutions, we use this part of the substitution up here. We use what u equals. But this time, we're going to use this manipulation. We're going to use the substitution what x equals. So that integral of 1 over x squared plus 9, I'll rewrite that integral of 1 over x squared plus 9 dx is equal to 1 over 3u squared. Let's not forget my integral sign. The integral of 1 over 3u squared plus 9. And then dx is replaced by 3 du. So 3 du. All right. So then what we'll do is we'll pull that 3 out as we normally do in a sub problem. I'm going to square out the bottom, so I have 1 over 9u squared plus 9 du. Okay, can you guess what I'm going to do next? I'm going to factor out a 1/9. So I'm going to write this. You wouldn't necessarily always write this, but just show where it came from. I'm going to factor out that 1/9. And then I just have 1 over u squared plus 1 du. Oh, see how that works? All right, so now 3 times 1/9 is 1/3. And the integral of u squared plus 1 du is inverse tangent of u du. All right, and sorry, there's no du because we did the antiderivative. It's plus c. And then I just sub my u back. My u is x over 3, so now I have 1/3 inverse tangent of x over 3 plus c, and that's what that integral is. All right. Now, you try to follow that same process. Just do the same thing. And I want you to do integral of, find it here in my notes, sorry, a little bit lost in my own notes, x squared plus 16 dx. You find that one. And then if you're really ambitious, state a general conclusion about integral of 1 over x squared plus a squared dx. This is what we're after, is this. So you do this. If you're really ambitious, tell me about this, and we'll check in on the next video.